Functions f, g and h are defined such that f of x is 1 over x minus 1, g of x is x squared, and h of x is the root of x. Determine the defining rule for f of h of x. So the function h will be done first here. And so root x comes out of there. Now, because we're going to be looking at a domain in a minute, let's think about the fact that x has to be greater than or equal to 0 going into h. That's then going to go into f. So what will come out is 1 over root x take away 1. So if we think about this, we can't have 1 going into here, because the square root of 1 is 1, and then we'd have 0 in the denominator. So our f of h of x is, as we said, 1 over root x take away 1. And then if we think about the domain, it's going to be real values greater than or equal to 0, but we won't be allowed 1, because putting 1 into h gives us 1 at this point. Determine the range for f of h of x. So it's a good idea to have some sort of idea of what it looks like. Now when x equals 1 we have an asymptote. We know we can put 0 in here, and that would give us 1 over negative 1, which is negative 1. And then as x increases towards 1, the bottom will become closer to 0, but still be negative. So that's going to go off down the asymptote like that. Then when we go to this other side over here, when x is just a tiny bit bigger than 1, the bottom will be close to 0, so it's going to come in from the asymptote. As x tends to infinity, the bottom's going to get big. 1 divided by something big is close to 0. So the x-axis will end up being an asymptote. So what we're going to have are real values where y is less than or equal to negative 1, so from negative 1 downwards, or greater than 0. Is it true that f of h of g of x is 1 over x minus 1? Well, it's false, and let me explain why. So the h was root x, and the g was x squared. So when we look at that part of it, or in actual fact, let's just do the whole thing. So what we're doing is we're going into g first, so we get x squared, then we square root, and then we go into f. So what we get is this. Now what they're saying is the root of x squared, x, and it isn't, because the square root of x squared has to be positive. So really what that is 1 over mod x take 1, not 1 over x take 1.